Assalamualaikum and hi everyone. So we continue with lecture 4 for a subtopic 1.4 definite integrals. So at the end of the lesson, students should be able to use properties of definite integrals, evaluate definite integrals, find the area of the region bounded, and determine the volume of a solid of revolution. What is the definition of definite integral? A definite integral is an integral with upper and lower limit, let's say from a to b. We will find the definite integral by calculate the integral at a and b and then subtract the value. Now let's look at the properties of definite integral. First properties, integration from a to b for a constant c is equal the constant c times the upper limit b minus with the lower limit a, where c is any constant. Second properties, if you have the integration from a to b for a function fx plus or minus with a function gx, so we can separate the integrations from a to b for fx plus or minus with integration from a to b for a second function gx. Third properties, if we have integration from a to b for a constant c multiplied with a function fx, so we can put c to the front and just integrate from a to b for a function fx. This is where c is any constant. For the fourth properties, if we have integration from a to the same limit a for a function fx, then the answer is always 0, and this implies for any function of fx. The fifth properties, if we have integration from a to c for a function fx, then we can divide the integration, which is we can integrate from a to b for a function fx, plus with another integration which is from b to c for the same function fx, where the value of b is between limit a and c. And for the sixth properties, if we have a function which is positive or greater than 0 for an interval a less than x less than b, then the integration from a to b for a function fx is also positive or greater than 0. Now let's evaluate the value of the definite integrals. Okay, we look at example 14. Find the definite integrals from 0 to 2 for e power of 4x minus 2 respect to dx. So we integrate the function as the same way as we integrate for an indefinite integral, but with limit. So the integration for exponential function is e power of 4x minus 2 over 4, and we put the limit from 0 to 2. Next, we're gonna substitute the upper limit first to the x, so we have e power of 4 times 2 minus 2 over 4, and we always subtract, and then we substitute the lower limit, which is 0. So e power of 4 times 0 minus 2 over 4. So we simplify the equation, so we have e power of 6 over 4 minus e power of negative 2 over 4, or we can give the answer in a decimal point, which is 100.823. Example 15. Evaluate the integration from 0 to 1 for 2x cubed divided by square roots of 1 plus x power of 4 respect to the x. Okay, first we look at the function. So I can rewrite the integrations as from 0 to 1, 2x cubed times 1 plus x power of 4 power of negative 1 over 2 dx. So we can multiply the integration of 1 over 2 to the front, and the integration would be 4x cubed times 1 plus x power of 4 with power negative 1 over 2 dx. So I have turned this integration into the form of f prime x times fx power of n. As we remember, the integration in this form is fx power of n plus 1 over n plus 1. So as we identify the form, so we can directly integrate this integration into 1 plus x power of 4 negative 1 over 2 plus 1 over negative 1 over 2 plus 1. So for definite integral, we just ignore the c and we put the limits from 0 to 1. So we simplify this integration. So we have 1 over 2, 1 plus x power of 4 power of 1 over 2 divided by 1 over 2 from 0 to 1. So since this 2 is a constant, so I can cancel out 1 over 2, and we left the integration with 1 plus x power of 4 1 over 2 from 0 to 1. And then by substitute the value of 1 into the equation, so we have 1 plus 1 power of 4 minus 1 plus 0 power of 4. So we have as set to minus 1, or we can write the answer in decimal as 0.414. Definite integral can be used to find the area of a region bounded. So first look at the area between the curve and the x-axis. Area under a curve can be computed using definite integration. Hence, the formal definition, if f is a continuous throughout interval a to b, then the area of the region between the curve y equals to fx and the x-axis from x equals to a to x equals to b is given by the integrations from a to b of a function fx with respect to the x. Note that the area is always positive, but we also can have a negative region when the curve is below the x-axis. So for the curve that lies below the x-axis, we have to put modulus of the formula to make sure that the area is a positive value. So for the area of the curve, we have to put the modulus of the integration from a to b for the function fx. And for the curve that lies above the x-axis, so the area is just the integration from a to b for the function fx. Next, let's discuss the area between the curve and the y-axis. If a function g is a continuous throughout the interval CD, then the area of the region between the curve x equals to g in terms of y and the y-axis from y equals to c to y equals to d is given by the formula of integration from c to d of a function g of y respect to dy. So as the curve is lies to the right of the y-axis, the area is positive, so the formula is just integration of c to d of a function g of y respect to dy. As we noted before, the area must be positive. For the curve that lies on the left of the y-axis, the integration is negative. So in order to make it a positive area, we have to put the modulus for the function. So the formula of the area is modulus of integration c to d for function g of y respect to dy. Now look at example 16. Find the area of the region bounded by fx equals to x squared minus 2x, the line x-axis, the line x equals to 0 and x equals to 3. Okay, now look at the solution. So in order to solve the example, I highly recommended that we roughly sketch the graph. So this is the graph that we have sketched. So from the graph, it is obvious that fx is a negative for interval 0 to 2 and fx is positive for interval 2 to 3. We divided the area as area A and B. Since the area A is under the x-axis, so the area is negative. So in order to make it positive, whether we put the modulus to the formula or we put the negative to the front. So the area of region A is negative integration from 0 to 2 for the function fx, which is x squared minus 2x. So we integrate x squared minus 2x as a definite integral. So we have x cubed over 3 minus x squared for x 0 to 2. and we solve the integration, and we have the area as positive 4/3. And for area B, since the area is over x-axis, so the formula of the area B is integration from 2 to 3 for the same function, which is x squared minus 2x. So we integrate the function. We have x cubed over 3 minus x squared for x from 2 to 3. And we substitute the value, and we have the area of B as 4/3 units squared. Since the graph is from 0 to 3, so for the total area, we have to sum both the area of region A and region B. So the total area is 4/3 for area A plus 4/3 for region B. So we have the total area as 8/3 units squared. Example 17. Find the area of the region bounded by the curve y equals to 1/x for interval 2 less than y less than 4 and -4 less than y less than -2, and also y-axis. Find the area of the shaded region as in the graph below. So from the graph, we can see that we have two different regions, which is I label as region A and region B. So region A is on the right of the y-axis and region B is on the left of the y-axis. So since the integration is about respect to dy, so we have get the function in terms of y. So we have the function as y equals to 1/x. So in terms of y, we have x as 1/y. So first we look at the region A. So area for region A is integration from 2 to 4 for the function which is 1/y respect to dy. So integration of 1/y, we have ln y from 2 to 4, and substitute the value. We have ln 4 minus ln 2. So we have the answer for area A is 0.693. And now let's calculate the area of region B. So for the area B, since the region is on the left of the y-axis, so we have to put whether modulus to the integration, or we just put negative to the front of integration from -4 to -2 for the functions in terms of y, 1/y respect to dy. So we integrate, and we have as ln y from -4 to -2. Then we substitute the value of -2. So we have ln -2 minus ln -4. So we calculate, so we have the final answer as 0.693 for area B. And then for the total area, we have to sum up the area A and area B as total area is 0.693 for area A plus 0.693 for area B. So we have the total area as 1.386. Okay, now we look at the area between the two curves. If function f and g are continuous with fx is greater than function g throughout the interval a to b, then the area of the region between the two curves y equals to fx and y equals to gx from x equals to a to x equals to b is the integral of function f minus a function g from a to b. So the formula of the area between the two curves is an integration from a to b fx minus gx respect to dx. So as we can see here in the graph that the region lies between the graph fx and gx for the interval a to b. Now look at the following example. Determine the area of the region bounded by the quadratic curve y equals to 2x squared plus 10, the linear curve y equals to 4x plus 16, the line x equals to -1 and x equals to 3. So from the graph we can see that this is the bounded region. So the area of the bounded region is given by the integration from -1 to 3. The upper function is the linear graph, which is 4x plus 16, minus with the lower function, which is the quadratic, 2x squared plus 10 dx. We simplify the integration as -2x squared plus 4x plus 6. And then we do the integration. So we have -2x cubed over 3 plus 4x squared over 2 plus 6x from -1 to 3. And then by substitute 3 in the equation, so we have 18 minus, and by substitute -1 to the equation, we have -10 over 3. So the final answer or the area is 64 over 3 unit squared. Example 18. Calculate the area of the region bounded by the curve y squared equals to x and y equals to x minus 2 as shown on the graph below. So from the graph, we label the bounded region R as the region between the linear graph y equals to x minus 2 and the graph y squared equals to x. From the graph, we have the interval of y from -1 to 2. So we'll have the integration with respect to dy. So the area of the region R is given by the integrations from -1 to 2 of the upper function, which is the linear in terms of y. So we have y plus 2 minus with the lower function, which is y squared respect to dy. So we simplify the integration from -1 to 2 y plus 2 minus y squared. And then we integrate the function, and we have y squared over 2 plus 2y minus y cubed over 3 from -1 to 2. Then by substitute the value of 2, so we have 10 over 3 minus, by substitute the value of -1, we have -7 over 6. Then the final answer is 9 over 2 units squared. Okay, that's all for lecture 4. See you in the next lecture.